So thank you everyone for joining. Welcome to our webinar on Modulus and using it in hard to reach places. I'm Abby Lindberg. I lead GelSight's applications engineering team. So just before we get started, a couple of reminders. We will be recording this, so it'll get posted on YouTube and a link will go out so you can reference it or send it to anyone who misses it. And we'll also have the Q&A active. So go ahead and ask questions throughout. We have Frank Chang from our apps engineering team answering questions live throughout. And we'll also get to some Q&A at the end. So that can be a little hard to find on Teams. You might have to click something on the top to access it. The chat is disabled, but the Q&A should be enabled. So use that throughout. We also have Dennis Lang joining us. So I'll pass it over to him to introduce himself and kick off the webinar.
Yeah, thanks, Abby. I'm Dennis Lang, CVO here at GelSight, and thanks for joining us today. We see some friendly faces and some new faces, which is great. We wanted to get this webinar set up today, really kind of based on the energy and enthusiasm we're receiving from our customers, the first ones who have been able to see the GelSight Modulus. And so what you're going to see today is a very kind of quick and practical webinar. We're not going to be going deep into tech in this one. That'll be the next webinar on Modulus at the end of the month, so watch for that. But today we're going to show you some real parts from the industries Modulus was originally kind of envisioned when we designed it, and really give you an idea on whether or not, as you watch Abby share the product, whether there's a fit for you as well. So we're not able to get to everybody as fast as we'd like to get the product on site, but as you think about it, reach out and we'll find the time. So with that, really the kind of philosophy of the GelSight Modulus follows the development path we have had at GelSight with our mobile systems. So 6-7 years ago, we launched the Series 1. Based on VOC with that product, we released the Series 2. And the Series 2 matched the performance and the field of view of the Series 1. However, it reduced the size of the head. So in other words, you got the same field of view, but better access, and it was smaller, which customers loved, and we've sold many of those units. Following that, we've really incorporated the voice of the customer. All of the feedback we've received over the years has really informed our efforts. But in addition to that, as we've had different products, we've been able to bring all those great product features into one product, in addition to new ones we call the GelSight Modulus today. So the true groundbreaking part about Modulus, beyond just the accessibility and kind of the aspect ratio of field of view to clearance, so mechanical clearance around the system, was to bring swappable lenses like an SLR camera. And this really follows a whole bunch of questions when we're in demos. Hey, I love this Series 2. Can I change the head? Can I change the angle? And so we have brought that as a true innovation to the mobile metrology market. We'll be showing that some more today. We, over time, kind of have customers tell us, hey, we really like this. It does about 50% of what we need with the Series 1. Series 2, oh, this is a lot better. This does 70-80% of all of our mobile kind of metrology needs and wants. And we really designed Modulus to do what I call 110% of what the customer wants. And so that being, not only are we able to do all the locations where metrology instruments and even sometimes replica can get, but even now Modulus is able to go into locations where nothing can go without destructively testing, meaning cutting the part open, doing a sample test, and hoping that matches. So we'll show more about that today. It's very exciting, but hopefully this just gets you thinking about your applications and some of the things you'll be able to do with it. The photo you see here is one of our early customer visits. We've had Modulus. We've been talking to customers directly with our systems for about a month. This particular one, you're seeing us on a CFAN engine doing an inspection around a fastener hole in an MRO or sustainment application. So, of course, when you pull a fastener out, there's a couple of different mechanisms that can create damage to the base material being joined, and that it could be corrosion, whether that's galvanic or moisture-based or other kinds of things that corrode the material set, or just the movement of the parts in service. So we're able to use the Modulus to get in there, no replica needed. That's what the customer does with this today. They put a replica material in there takes tens of minutes, then they have to go back to the lab. It takes hours to days to get that process done. Here, it's just like the GelSight many of you are using today. One click, you got a report in the second click. So in seconds, you can have that same result. And it's really been a game changer that's it's unbelievable excitement. So hopefully we're going to be communicating some of that with everybody here today. But with that, I think it's really important to point out as Abby goes into this, but be explicit about it, that the GelSight Modulus was designed to work within the same paradigm of our GelSight mobile systems. So it works over USB-C plugged into a Windows 11 computer, oftentimes the Surface tablet we include in the Pelican case. It works with the GelSight mobile software. So all of the analysis routines are the same. The capture of the routine is the same. In addition to that, you can hot swap. So if you are in situ and you are using an S2 because you like the field of view, and in fact, many of our customers want kits. They are buying our early orders, oftentimes include the S2 and the Modulus. You can unplug your S2, plug in the Modulus, and go to a location like you see here in this photo. In addition to that, the lenses on the Modulus are hot swappable. So you'll see that when Abby shows it later. You plug in the Modulus, the system automatically recognizes it. If the Modulus body is attached to a lens, the lens with the associated calibration for that gel is also automatically updated. The system changes the live view to match the field of view of the product, and you're off and running in seconds. And you'll see that live today. If you are using a straight or the 90 and you want to transition to the other Modulus lens, you can hot swap it as well. You don't even need to turn off live view. You can unthread it, thread on the new one. You'll see the system recognizes the new product. The LEDs will come to life for the live view, and you're off and running. So it's truly innovative. There's no need to set up, of course, like any GelSight measurement, there's no need to coat, set up reflective things. It's a direct measurement. It works every time. And we really are excited to be able to show that to you. So with that, Abby can get into the demo we're talking about here, and I think you'll see what I'm talking about.
Yeah, I think I'll start with a little bit about how Modulus works and kind of compare that to our other systems like Series 2 and Max. And then we'll get into the scanning of the samples that I've got on the desk here. But I'm holding up Modulus with the straight lens. We've got the body, which is the camera in it, and we've got the lens, and we've got the gel. So I'll actually take the gel out to show you what's in here. You can see we've got several banks of LEDs, and this works in the same way that our other systems do. So when I click this button on here, I'm taking a series of images with different lighting orientations, and through a process called photometric stereo, we get a normal map and 3D data out of that. And then that works in conjunction with our gel sensor here. So this is what's going to allow us to look at surfaces regardless of optical properties. So we're looking at everything through that pigment layer, just as we are with our other systems. And basically eliminates any issues for transparent materials. And I'll actually just drop that gel back in and twist it into lock. But really kind of the key difference here is that we've separated the camera and the lens. And that's what allows this, modular aspect of Modulus, right? So we've got the body and the lens, and that's what lets us swap our lenses. So you'll see I'll switch back and forth between these throughout the demo. But I've got our 90-degree and our straight lens, and we'll just be able to switch them for different applications. So I'll actually switch the camera over so we can see the desktop here so that we can look at what we'll take some scans of. So let me swap my camera here. And now you can see my desk here. And before I share the GelSight mobile screen as well, I'll hold up the samples that we're going to take a look at. So the first thing that we'll look at will be a turbine blade, and we're going to take a look at the root area here, a defect on that. And then we also have a two-piece segment of a blade with some part marking. We've had a lot of part marking applications coming up recently. And then we've got a jet engine Y-connect with a bunch of interesting geometry on here too that we couldn't previously access, if there's a defect in this area here or even internally inside of here. So we'll take a look at different areas on here. And then finally, we have a piston with a wrist pin bore that we'll take a look at, and we can access, almost all of the geometry as part of this. So we'll go through taking some scans on all of these components. All right. So before I share my screen, it's gonna, when I share the screen, it's gonna take up most of it. So you can actually switch between the main view by clicking on the camera. So if you want to see more of the camera view, go ahead and click on my video. If you want to see more of the screen share, go ahead and click on the screen share, and you should kind of see one get larger. So whatever your preference is, depending what you want to see. Now I'm going to go ahead and share the GelSight mobile software. Click share here. And we'll go live. All right, so now I'm connected to my straight lens. I'll actually just press my fingertip into it so you can see kind of our favorite demo we've got there. Give an idea of the resolution. And then I'll take our turbine blade and we'll take a look at the defect towards the root here. So I'm just going to press this onto the surface and you can see it pick up that defect. And I'll click the button to take the scan. Just as we've done with all of our other systems, you'll see, the software is the same. Our 3D data is generating now. And then we'll be able to open that up and use our same suite of measurement tools. So I'll go ahead and open up the software here. When we see our defect, we can look at this in 3D. So here's that surface reconstructed. And we'll jump back over, and maybe for this one, we'll do our defect detection function. And just to show the full workflow here, we'll click Analyze. We'll get the characteristics of that defect as well as the profile through the deepest point. And then, one touch PDF reporting takes us here, so you can attach this to whatever system you need to upload your reports to. So kind of customize the view and whatever information you want included in that. But let's jump back over to Capture and take a look at some of the other samples that we have here. I think one that's been interesting, I mentioned we've been having a lot of applications recently for part marking. So we've got an example of that here. We have a spec for how deep these need to be, but they also can't be too deep so that they'd be damaging your part. So I'll kind of let us press this onto the part here and click the button to take the scan. Right. Typically, this is done with just like a pin gauge, having to look at every single part, every single dot pinned part of that serial number. But this lets you do that in kind of bulk groups, basically. So I'll open this scan up. And I'll use our pit detection function on this. I'll just click pit detection. We'll run it on the full field of view here. And you can see it picks up all of those pits and actually gives me the characteristics for each pit in the field of view. So you can get all of those depths for all of these pits in one swoop. And this is also the function that we use for corrosion applications as well, because you're kind of characterizing multiple pits in one area. All right, so I'll switch back over to Capture and we'll look at some areas on our Y-Connect here. We'll hold this up. So this has a bunch of areas that we couldn't previously access. So I'll kind of look at something in this area here. Maybe we wanted to look at these scratches on this. I can click this button and take the scan. That's right in the area where that Y comes off. Additionally, we could kind of turn this around and get access into this area with this weld. Maybe we were looking at some defect along this weld, or like an undercut or something else. We could have access here. Or even maybe along this kind of interface here, where we also wouldn't have had access before without replica material. I'm going to press onto that surface. We've got a bunch of miscellaneous scratches on this part here, or potential corrosion in some of these areas too, maybe some early corrosion right there. But now if I want to access the inside of this, we're just going to switch over to the 90-degree lens. And to do that, you mentioned hot swappable, so we'll watch that now. But basically, I'm just going to twist our locking ring here, take out my straight lens, and I'm just going to swap it with my 90. So you'll see the 90-degree one right here. Just going to drop it into place and lock it in with that locking ring again. And the software just kicks back up with my new attachment, and now I can just switch over to anything I can access with the 90-degree. So I'll come in here. We'll look at something inside of this region here. So we could look at, this weld internally. Or maybe we want to reach further into this part and look at a defect where the Y tees off inside of this part. And look in this area here. I can see some scratches along that edge. Or maybe this defect here. And just click the button to take the scan. And Modulus is equipped with mounting holes as well. So you can see when I'm holding the probe up right here, the body has mounting holes. And we have CAD drawings and also the just dimensions for this to allow our customers to 3D print or design their own accessories for this. So we've heard GelSight on a stick being used as an option for this, but basically extending the length of this to access further into bores. Then you can trigger through the software. You don't have to use the button on it, but basically the option to let our customers accessorize this how they need to for their application. So I'll take our last sample now. We'll take a look at that. We've got our piston again here with our wrist pin bore. And we'll take a look at a defect inside of here. But I mentioned we can access almost all of this at this point. Dennis said 110%, but something like that, right? So I'll take a look at a defect inside of this bore here, and then we'll see what else we can access as well. So I see there's a scratch here. We'll kind of just come in here and take a look at that and click the button to take that scan. And now it's just generating our 3D data, but you can see we can access a bunch of different faces of this, internally and throughout that bore right there. We'll open that scan up, and this is an example of another area we could just use our defect detection function on. We're looking at such a small area here. It looks pretty flat to our system. We can see this little pit right here is actually deeper than the rest of this scratch here. So it's drawing a line through the deepest point of that defect and giving me the characteristics of that. Now, I'll jump back over to capture because, what if I want to access something at the bottom of this piston now? So we'll just switch back to our straight lens. I'm on our 90 right now, and, we'll just twist that locking ring and switch back to the straight lens. And just put that right there. And we'll drop our straight lens in and connect that. There we go, pops back up in the software. And now we're ready to take some scans. So we could look internal to this part, something like that. We've got some part marking in here. Maybe there could be some defects, but just as an example, we could measure the surface roughness internally for this. And that's something that's pretty challenging for other systems. I mean, it's a hard to reach location. It's also got a complex geometry at the bottom there. And that's not going to be an issue for the straight lens for us. So we'll open that scan up here. And just as an example, we'll go through and we'll do a profile roughness measurement, maybe even with multiple profiles. And we'll click analyze and we can get the average RA inside of this piston. So I'll kind of just talk a little bit about the geometry of this to give you an idea of what kind of spaces we can fit in. I'll stop sharing this so that my video is a little larger, but the bore that we're looking at here is a 2-inch bore. The access for this 90-degree lens, this width is about 1 inch. So you can see, kind of hold this up here. A lot of space to access it. Hopefully I'm not blocking it with my hand, but you can see plenty of room to access in this 2-inch. Take up about 1 inch in this orientation. And then getting to the bottom of this area here, it's a little wider at the top, but when we get to the bottom down there, I'd say it's probably just under an inch. And the access that you'll get with the straight lens, this width is about 16 millimeters. So that's what we're going to have to get into those tight spaces. And I'll actually pull up a slide here to show kind of the difference between some of the dimensions of some of our other systems and how Modulus compares to that. So let me pull that up. I'll actually switch my camera back here too. And I'll share. We've got our slide. All right. There we go. So you can see kind of how these stack up compared to, our Max system at the top, Series 2, and then Modulus at the bottom. In the bottom right corner here, you can see that about 1 inch for access for that Modulus system. That kind of green circle is representative of fitting into that 1 inch bore. And then you also see the trade-off on the right-hand side of your field of view. So obviously, it's a much smaller system now compared to Series 2. You're going to have a smaller field of view that you're able to see. So that's kind of where the complementary nature of switching between systems really is a nice option, since we can just unplug Modulus, plug in Series 2, or just swap between our lenses there. So Dennis, maybe you could talk a little bit about the value that GelSight brings for these types of applications.
Yeah, thanks, Abby. So as we showed with the image I spoke to earlier with the engine, one of the things our customers talk about, given the access of GelSight Modulus today, is they're going to be able to replace replica workflows. So of course, replica workflows, you have to bring a material into the environment, which carries its own risk, a gel-like material that you have to mix and apply. And then of course, you have to pull that replica off. You have to get it to the lab. That takes a long time. So GelSight's been replacing workflows related to replica for a long time. And in fact, in our software, we actually also are able to look at replica and measure replica materials. But in addition to this, I talked about that 110% earlier. And I think when you hear Abby talking about, we've created a product with the ability to create an accessory, the user can create their own accessory, their software triggering of the system. And as part of the development effort, one of the other things we've added is the ability to use much longer cables. So we will be stocking 2, 3, and 5 meter cables for the Modulus, which is another thing we've had requested of us. And actually, some of those improvements will apply to GelSight Mobile Series 2 as well. But this allows you to go into places that you either had to destroy before or had just complex test procedures. Much, much easier using something like this. So to give some ideas of what we're hearing from our customers when they look at Modulus and they think about their test plans, we're hearing an 80% reduction in the complexity of their test plan, meaning they can bring the GelSight system in with our software package that allows all these different analysis options, with the ability to use an S2, a Max for your fine roughness and features, and a Modulus for access and other locations, and the ability to go into bores. This is just an amazing change. Really, there's no product solution on the market that gives this sort of a capability. We're also hearing the ability to reduce the turnaround time in a sustainment or MRO environment of days. So when you think about an aircraft that is able to be released back into service and cleared to operate that much more quickly, you can think about this as a millions of dollars impact or an availability impact in the case of defense applications. So very important. But the overall and the overriding value proposition we bring is micron scale measurements with incredible speed. That's really kind of the GelSight ethos, and that's why our customers are buying the product today. So all of these features have been built around bringing that to you guys to really enable your measurement to match the pace of digital development that you're using in your workflows. So this is just the beginning of the journey. GelSight Modulus, as we said, we have swappable lenses. We have 2 that we are coming to market with today that are ready to order today, and customers have been ordering. But in the coming quarters and years, GelSight will be releasing a larger and larger portfolio of lenses leveraging this technology, in addition to other exciting things to come. given the overall kind of concept for the product. So please ask any questions here today. We have a couple of minutes left. In addition to this, feel free to reach out. We're happy to get you on the docket and get on site with you to measure your parts.
Thanks. And for the next webinar, we're going to get into the technical details of measuring scratches and defects and show our new auto offset feature. But just as Dennis said, we'd like to bring the GelSight platform to you guys. So that includes Modulus. So definitely reach out to us with requests for visits. We want to show it to you. And with that, we'll get into if there are any questions. Go ahead and use the Q&A feature that's in the Teams button. You might have to click more at the top. It kind of depends on your view on Teams. But let's take a look at what questions we've gotten so far. All right, we have one that says, what is the minimum depth that the unit can measure? So for this system, we're going to be measuring down to about 5 micron for defects. And that's about 5 micron to 1 millimeter is what we have tested up to. Is the calibration procedure the same? We do have the same calibration feature. It does have a new fixture, but to kind of simplify the calibration process and improve the calibration quality, but it is the same process with the flat, the ball grid array and the groove target. And it is still user calibratable. It's still just 6 scans, takes just a couple of minutes once you've done it before. We have another question here. It says, is there any plan to make an even smaller attachment? Dennis, you can answer that one.
Yeah, there is. That won't be this year, but next year we have some exciting stuff we'll be releasing. Absolutely. Since I have the the microphone, the mic, I would like to. Mark asked, when swapping lenses, how is calibration maintained? And this is a really good question, Mark. It is maintained because the lenses are serialized, so the system, when you plug it in that hot swap function, we sense the lens that is in there, and the calibration for the gel that is in the lens is kept.
Thanks, Dennis. We have another question here. It says, what is the expected life of the gel sensor? It is a consumable, so they do get replaced. Right now we have lab numbers for that, but we're still working on getting the in the field numbers. So right now we're seeing kind of a similar, if not a little bit better than what we're seeing with Series 2. But Dennis, feel free to add to that if you want. I'm not going to give anyone numbers. It's kind of application dependent, but go ahead.
Yeah, we know Series 2 today, is 300 to 1,000 plus, depending on the application, the cleanliness, and some other things. We are definitely seeing longer and longer lifespans with Series 2, and the Modulus gel was certainly designed. It's an entirely new gel, and it was definitely designed around keeping the sensitivity to residues left, to silicone being left on parts and certain aerospace applications that are very sensitive to that, but also allowing it to be easier to clean and have longer life. So as Abby said, we've done our internal machine testing, and now the field testing has started. Early indications are it's going to be a better gel as designed from a durability standpoint, but we'll have to see.
Thanks, Dennis. It looks like we have one other question that says, which force needs to be applied for the measurement? And it does depend on how deep of a feature you're looking at, but it's pretty minimal. I think you saw, I just press on the tip of here and it'll pick that up very easily. It is a pretty soft gel. Kind of the idea of it is to be kind of the hardness of your fingertip. So if you imagine kind of how hard you would need to press onto something to feel it, that's basically an idea of that.
For the users of like the S2 system, it would be less pressure.
Yeah.
Because it's a smaller gel. So.
All right, well, I think we're at time. So thank you all for joining. And as a reminder, we'll be putting this on YouTube. So we'll share that there. But once again, thank you all.
Thanks, everybody. Appreciate your time today. Bye-bye.